Hang on, like I do so few collaborations. I have no format for them whatsoever.
But that's okay.
Yeah.
Less format is good for collaboration.
Good Monday morning.
Hello.
Hello. I am MPJ.
Hey, I'm Irina.
And you are watching Fun Function.
Fun.
So it's all right. Who are you? We can begin with that.
Sure. Hey, I'm a developer. I program in JavaScript,
Yes.
Node,
Yes.
HTML, CSS on occasion. I live in London, and I'm here in Stockholm, so
Yes.
This is cool.
But you're not from London originally.
No. So I just moved to London.
Because you go a boot.
A boot. I don't say a boot.
No, you don't.
No.
But it's still like not the British about.
A boot.
The boot. Yeah.
So I only just moved to London 3 months ago.
Yeah.
I was in Vancouver beforehand, which is why I don't say a boot. That's only in Eastern Canada. Very common misconception. Common misconception, I think. Yeah, so in Vancouver we don't say a boot.
All right. And we know each other because we were both doing talks at Brazil Jazz.
Yes, that's true.
And you did a talk about cellular automata.
Perfect.
Is that how you say? Like,
even though it took me like 100 times practicing saying cellular. No, I said, damn it!
I'm thinking like I have this idea. I don't know if I'm gonna like be have the attention span to do it, but I'm thinking about having a counter in the upper right or left of the screen where we're like the number of times I mispronounce cellular automata used during this video.
I think you should do it for both of us because I still don't say it right all the time. And I mean, I've given that talk more than once.
Yep.
At this point, I should know.
Like cellular. Shit. All right. It's impossible. Okay. All right. So, like,
let's actually talk about it rather than like try to pronounce it.
Yeah.
Okay. So, cellular automata is a concept of neighborhoods. It's been put together by a bunch of different smart computationologists. Okay, that's not a word. I'm making it up.
No.
And it's basically a set of configurations that different cells take on. And what these configurations do is that over time you get this, I guess, pattern that comes up. I think it's better to just start and show it because then we can talk about it a little bit more.
So
I've put it together on my GitHub. Whoa, what's up with this keyboard? Okay,
yeah, it's a Swedish keyboard. Like, but I can switch it to
Can you tell me where the forward slashes?
The forward slash, but now it's American. Should we switch it?
No. This is. I'm not American.
No.
Canadians take offense to being called American.
Yeah, but you're like, do you have the same layout as the US International, or is there?
I don't know. I have a Canadian layout, but that could be just like tomato. Cool.
All right, cool.
So I put it together. This one's following a set of configurations called Rule 110.
Yeah. So this is not an image being rendered. This is actually rendering like on the fly.
Yes, that's true. So there was this computationologist. I'm totally making up.
We're computationologists. That's also another great word to mispronounce.
Wolfram that put together a set of rules basically for these automata to follow.
Yeah.
So what happens is you have a lattice of cells.
Yeah.
Lattice is an array or just like a string of different cells.
What is the difference between a lattice and an array? Why do you use the word lattice?
Because a bunch of like papers I've read on automata use the word lattice, and so now I'm just like lattice.
Yeah. It's a pretty good word.
It's just like an array. I'll have to use array because I don't know why I say lattice because nobody ever says lattice. I don't think.
Okay, well, lattice.
Structure consisting of strips of wood or metal.
That is amazing. Why do you like?
No, I don't know. I think
it's like what. It's this thing. Is this a lattice? Like
what? Okay.
What?
An array. Let's just call it an array. Yeah. I don't know. The papers I've read called it a lattice, and I'm like, I must like sound old. Like I've read papers, so I'll keep calling it a lattice.
Yeah, let's check it. All right.
So the initial kind of configuration consists of an array of these cells that have a random state, and a random state is it's binary. So you're either 1 or 0, or in this case, you're either green or you're gray. And over time, so you can see like these cells over time, you change your state, or like the cell will change your state. Okay, and the state is dependent on the two neighbors to the right and to the left of you. And so over time, you obviously change your own state, and then over time you change your own state again and change your own state again. And what's super interesting about it is the fact that if I were to refresh this page, like you can see like these triangles going down. Actually, let's zoom out first.
Oh, I'll zoom out.
Oh no, like you can see that this is an entirely new, like on a refresh you get an entirely new
this
difference.
Is not the same thing. So if I look here up in the right, in the left.
No, the random state. But the super interesting part about it is that you have these patterns and the same kind of spatio-temporal patterns come to mind, and they're all kind of like, how do you zoom out? Swedish keyboards. Okay. Like on a zoom out, you'll still have these triangles going down, and it's really interesting, and they keep going down and they keep going down, and I'm going to refresh. And I'm going to get different position of these triangles going down, but there'll still be triangles going down, which is super interesting. And
so there's randomness, but there's still like a pattern to the randomness.
Yeah. And it's incredibly fascinating. I think people have been super fascinated by it and try to kind of see where they could get.
So this like when I saw your talk, I had no idea what cellular automata was. But once you started talking, I started like, oh, okay, so this is the Conway's Game of Life thing. Is it related to that?
It is related to that.
But is Conway's Game of Life cellular automata?
No, so it's related, but with Conway's Game of Life...
Can we just show Conway's Game of Life?
Yeah, let's I don't have one built personally, but there's...
Let's say Conway's Game of Life. There's probably something on it.
Should I draw this?
Yes! Okay. Let's do it.
So before we show it, maybe.
Yeah, okay.
Or let's show it first.
Okay, let's show it first. So this is... I just click the first result.
Yeah.
This might be horrible. Let's see what this is.
Dating Ukrainian women? What the fuck is that? Sorry.
It's just...
Oh, these are blasters. This is a blaster. Actually, I showed that during my talk because I thought it was like... This is Star Trek 101.
So what are we looking at?
So with this, like, if you remember the one that I was showing, what was happening that over time you progress down, and like time changes as you go down. With Conway's Game of Life, you set up a canvas.
Okay.
Basically, and that's kind of your life, your entire universe is this canvas, and over time the entire canvas changes, so you will have the change on your entire universe. And so these cells they're also dependent on your neighbors, but they're dependent on your neighbors around you rather than just the two. So they call Conway's Game of Life a two-dimensional binary cellular automata, which means that two-dimensional is the fact that you don't just care about the neighbors just to the right and to the left of you, but you care about everybody around you.
Alright.
So I can draw that. I don't know.
Yeah, awesome.
Okay.
That's great. Alright, so what's your... You have a tattoo on your... Like, or it's like, why do you have... Like,
hold on.
Yeah, alright, can you... How do you...
How do it?
I think that's too close. It's 2 exclamation marks.
That's bang bang.
Oh, okay. What is bang bang?
Like truthy value. To get a truthy value, you would bang bang.
Yeah, sure.
JavaScript.
Yeah, so you have the bang bang. Like that's just what it is. Like,
yeah, that's exactly what it is.
That is so awesome. That's an awesome tattoo.
It's like the biggest nerd tattoo I have. This is you. And this is your neighborhood, and you kind of just go around the neighborhood, and your state depends on what your neighbors are.
Yeah.
And there could be either the smiley face or the shaded.
Yeah, so all these little dots on screen.
Yeah, all the little dots are basically that.
Yeah.
Which is pretty cool. Like, I mean, you start, like, your universe has to be pretty large to be able to take any effect. Like, this, and with Conway's Game of Life, everything is kind of dependent, because the rules are the same for any kind of game of life. It's dependent on your states around you, and it's kind of like a majority rule kind of thing. But everything is super, super dependent on how you start off.
Yeah.
So this one has you will be able to achieve what we saw on the screen basically by the initial configuration. But the reason why people are so interested in it is because it's a really kind of very broken down method to look into a specific problem you're trying to solve. And I think that's super fascinating in general. I think people have been working with the one-dimensional, that's the green and gray one on the screen. People have been working with kind of this concept of automata and try to work with it with image processing and like fixing topographical maps and things like that.
What with like more practically, what does it mean? Like image processing, more specifically, what kind of image processing?
Like the blur effect. If you do like a filter of a blur effect.
Oh, like a Gaussian blur and stuff like that.
Yeah. That's essentially like if you were able to train an automata to be able to blur a picture on a certain way, you're able to. But I think we were saying let's build one.
Yeah, right. That's true.
Okay. What's your setup?
All right. So we have very different.
I love setups. Setup talk is like.
I love setups. Like I have this. I basically have no setup. That's like my. We talked about this.
It's very
before.
like normcore. I feel like that's a Swedish thing. Like.
My setup is normcore. I don't have a setup. Like my setup is, I have this episode where I talk about what editor you use, and my editor is basically just Atom with almost no plugins at all. I have this idea that I should be able to just like fiddle with my laptop and drop it into a lake, and then walk into an Apple store and just buy a new laptop and start working on it almost immediately.
Yeah, that's very practical, I think.
Yeah, because that often happens. Like
you often drop your laptop into a lake?
No, I don't. Like
Tell me more.
It's just a completely.
What is that?
It's just a completely hypothetical scenario in my brain. It's just me, like some kind of weird insurance thing. It has never happened. It's gonna be like useful to like 2 times in my life or something like that. Okay. I'm looking forward to them because I feel like vindicated for not using any tools.
Yeah.
But you're the complete opposite. You use like what's it called? You use a kind of Moon Emacs. Oh.
No, Space Max. No,
he wasn't. No. What? What the? Like I have never heard of Space Emacs.
Okay,
Space
no,
Max.
it's Space Max.
Oh, because there's an E at the end.
Yeah, so space. Right. It's very spacey, honestly. Like, it's pretty cool. And essentially, it's Vim on steroids. So you use Vim key bindings.
So you use Vim key bindings on Emacs.
Yeah. Isn't and like a little bit of like you still use some of the Emacs stuff.
Yeah.
But when I type using Vim shortcuts and things like that. Which is, I used to use Vim before. Actually, when I started programming, I started with Vim. I used Atom for like 3 weeks. And it was like when Atom came out, and so it was buggy. A little bit buggy.
Oh, yeah, it was.
Like very buggy. In terms of like Git wouldn't sync. Anyway, sorry, we were going to build stuff.
Yeah, like my only customization, by the way. How do I, that. Like I changed like my terminal thing. And you have also done this. Can I just? I'm gonna do just to show. This is probably the easiest way of showing. So you have a bear like shooting particles.
Yeah.
Yeah, and like this thing. What like you use this for state in Git?
Yeah. So this is like a fuzzy state, meaning I've been lazy, I haven't committed. And this is I'm queen state, so I've been good and I've committed.
Oh, so these are, so when you commit something, like, okay, change. When there's like things that are modified but not yet committed.
Yeah.
That is amazing.
It's pretty useful, honestly, because sometimes I go into the repository 2 days later and I'm like, oh shit, I forgot. No wonder things are not well in staging land. Yeah.
All right, but we digress.
Yes, yeah. I mean, I can talk about configuration first.
Like we're probably like 20 minutes in now, and we have like
not even coded anything. Okay, cool.
This is gonna be like a 4-hour episode.
Okay, let's do it.
All right, cool.
So I think like, what are we doing?
All right, we're doing like you have an implementation of this green thing.
Yeah.
What's it called?
So that's just Wolfram's rule number 110. It just follows the rules. So with Automata, everything's kind of rule-based, or your outcome depends on how your cells follow the rules. And so Wolfram came out with 256 of these rule permutations of this rule, because that's combinatorics.
Like Wolfram, is that the same person that Wolfram Alpha refers to, or is that a different Wolfram? Like
I don't know about Wolfram Alpha.
The search engine Wolfram Alpha that you can do a lot of computations in.
Oh, I would assume that's the same person. Actually.
Yeah. Okay. Yeah.
Right.
There is not multiple
Wolfram
famous what's a computerationists.
I don't know. I'm making that word up.
Yeah. All right. Yeah.
Yeah. So that one's following rule number 110. I just wanted like a nice display of what I was working on. And so I'm thinking we can build one but follow a different rule.
Yeah, sure.
Just to get a sense of like how that works.
So I guess I need to start, so I need some, let's just, I guess I just do some, no. Let's just open that.
Yeah, let's do that.
Oh no, it opened in another window. I don't know how to do webcasts. Go. I want you to go there. There. All right.
Cool.
Cool. Now it's here.
Awesome.
Cool. And then open rule thing. HTML. Or nice. Now we're here. Yeah. Cool. Oh no! Now my Canadian keyboard.
You can use the Swedish one. I'm sorry, I'm making you.
All right. Let's do this.
Excellent HTML tags.
All right. Cool. Let's begin. So.
Oh my god, you remember that by heart?
Which one? Bodo.
I have to look that up like every time.
The HTML body.
Yeah.
Like, but I started as a web programmer. Like, so this is probably like the first programming thing that I ever did. So, but
my memory not so good.
Yeah, but you're like more a general programming than me, right? You're not a web developer.
I do web things actually for the most part, but I also like build CLI things.
Yeah, I've basically never done anything but web.
Okay.
So how do we begin this? Like we need a script here.
Yeah, probably. Let's bring a script. Do you want to do it like straight up in the document or have?
Let's do it in the document at first, and then start breaking it out in the file as we go.
Yeah.
Do we think? I'm not sure if you actually need to.
No, you don't. I think if it's inside.
Yeah, you can just go.
Awesome. Or do you use the let stuff?
Okay. Yeah, I use the let stuff. Yeah, I use a lot of
I'm so like old school. I just
yeah. I'm gonna like try to get you onto the ES6 train. Yeah.
So I think we need some cells to begin with.
All right. So how do we do that?
Do
we do some divs?
Yeah. Let's make some divs.
Cool. And
basically, I think the initial thing is just going to be like, instead of an array, it'll just be a row of cells.
Okay, cool. So how many cells?
To get a good picture, we need like 100.
All right, so I need to create them dynamically.
Yeah.
How do you do that? Okay, so I guess I don't remember how to code. Like, let's just begin with a for loop. Oh, I have a.
You can like, I mean, we don't have to unless we want to be like super fancy. We can just copy paste 100 cells.
No, let's
Okay, okay.
I don't want to copy paste 100 cells. Like,
Okay.
that makes my programmer soul go like and while I is less than
let's do 101.
yeah.
Because we need an uneven. Uneven is odd in English.
And yeah, and we need to create elements. I don't know exactly how document.create element.
I think so.
Div, guess something like this, and we need to append it. I think document. What's that? Append? Can you look that up? Like, is it append child or something?
I need to agree to some privacy.
Remainder by Google.
Yeah, I'm sorry.
Yeah,
that just
Google.
like popped up and I couldn't do it.
Google is just like, remember
append
this
child.
thing. Append child. Div. Okay, I think that's maybe that would work. See.
Well, the thing is,
If you have to execute append child on node, only one element on document.
oh, we need a row element in the body, I think,
Oh, okay.
and then we can append child to the row.
Something like that.
Yeah.
And we'll find that. Get that by ID. Whoa. This is advanced computer science.
It's perfect.
Right, let's see. What is it? Ah, yes, it's a ton of divs. Success.
Oh my god, so
Yes.
many divs.
Yes, that's amazing.
Yeah, cool. So the divs now. Okay, we should see the divs.
Yeah, okay.
Let's write some style tags.
All right.
Like serious programming mode. I need my hair up.
Right. It's the wind is troublesome. All right, head. How do you do this? Style.
Yeah, I think it's just a style tag.
And let's call these. Let's just go like row div.
Give them a color.
What color? Is there a color picker here? I think it. No, I don't have a color picker. I only know one hex code from heart, and it's this one for some reason.
Not FFF.
Not. Oh yeah. But
Like, I mean,
that's cheating. Like, but an actual color. Okay, they don't have it. Why does this not work? Is it because they don't have a? No, it's because it's not a class. It's an ID. No, it still doesn't work. This should work though. But I think it's because they don't have a width or something. Hang on. No, they should have. No, they have a width, but they don't have a height. I think. Now it works. Now it does.
Hold on.
I need to explain. Now they are visible. Why are they? Oh, I need to have a background color.
Right.
They don't have a color. Like, all right, now we have something.
Excellent.
Excellent.
It's huge.
Okay, now it's huge. Like, let's call them 10, and then like, yeah, it's still just gonna be blue. We need like some margin bottom or something. Like 10 px.
Probably. Yeah.
Ah.
Okay, and we're gonna need to have them display things.
Display inline block. I think that did absolutely not work. Oh, but now perhaps they need a width. Yeah, and now they also need a margin. I'm just gonna move the. Okay, now this actually looks like something.
Cool.
They don't need that much of a margin, right?
Yeah. That seems We're gonna have to align it so then it's just all in one row though at some point. Actually, let's do that right away.
All right, cool.
Because then we won't.
All right, camera stopped. All right, so we were talking about line heights, and I asked if we wanted to have more rows, but we don't want that. Like we're gonna build that as we go. Sneezing break.
Yeah, so that will happen as we go, because essentially what each row is 1 year in the life of Automata.
Yeah, because everything is like life terminology. We're building like
a lot
representations of life.
Yeah, that's a good way to put it, for sure. So we'll just have to duplicate it with JavaScript.
Yeah, okay.
JavaScript.
Okay.
Let's actually grab the cells. Oh no, so let's start off with the fact that we need a random position in the first place.
Okay.
And we need a random position with 2 different states, active or inactive.
Yeah.
Okay. So first thing we did was on 17, we've created cells. Cool. So then we'll let's set up a random function.
All right, cool. All right, so we need some kind of math.random as a base, I guess.
Yeah, math.floor.
Oh, I keep forgetting how to do this.
Oh, I Google it every time. I don't think
it's times
max,
something like that.
Just return it. Yeah.
All right, call it. Let's see what that ends up being. All right. How?
Okay, so now what we need is we only need 1 or 0. So this gives us a random number.
Oh, okay.
So we need a 1 or 0.
0. Okay. How do you do that?
Get random. So we need to pass in a min and a max to the function.
To the math.
To the random, yeah.
Okay, cool.
And then when we do the times 1000, I think what we'll do is we'll times it by max minus min.
I don't understand that. What do you mean? Like it?
Okay, no, that's actually let's get rid of min and max.
Okay.
Screw that. No, we know we'll only have. Okay, so let's we don't need to times it by 10,000 because I think that, or 100,000.
No,
because I think that gives it the maximum that it needs. And I think what the math. Let's Google what the math random function just takes. No?
Yeah, does it take any arguments? I've
Yeah,
never
I think
used
it
an
does.
argument, given an argument to it.
If you want a random integer between something,
you
will times it by the max minus the min plus 1.
So our max is basically then...
Sorry, that's math floor that takes an argument. Math random doesn't take an argument.
Okay, interesting. So, so how do we do this? Like, walk me through this.
Okay.
Was it max minus min?
Yes. And then
we need a max and min. What's the max and min?
Well, the max is 1. We can just set it. It's max is 1. Min
0.
Yeah. And then max minus min, and then you go plus 1.
Like plus 1.
Yeah.
Here. Right.
This is straight up from developer.mozilla.
All right. See. So now it's just okay. This seems to work actually.
Yeah.
This seems random to me.
Yeah, that's awesome.
Cool. So now we have a random function that random binary.
Random state.
Cool. What do we do with this?
Okay, so now given the fact that we have a random binary state, we need to assign that to each div we've created in the function above or below.
Cool. So
I think we're gonna have to.
Let's do that. I guess we'll do that here for now, just to get the act. So do we call this active or inactive or something?
Yeah, let's create a class active and inactive.
Active, and we call that background color red.
Red, okay.
It's
gonna be some major color. And then inactive can just be the 990.
Yeah, that's true. Well, so sorry.
Okay.
Okay.
So we were looping through that. Let's just
okay, so we just do random binary, and if that is no, so we can do just this.
Active or inactive, yeah.
That is.
Was that our alarm? No.
No. Okay, that did not. Div add class is not a function. How do you add a class? I thought that I thought this would work.
Add class.
I obviously don't know web. No, that's a jQuery thing. It's like class list add or something, right?
Yeah. Hold on. Yeah, maybe that's what it is.
Class list as. Sorry, Freudian. Right. Oh, look.
Cool.
Yes, we have something.
Nice random state.
Yep.
I love that you remember the class list add thing.
No, it was like in the back of my mind.
Class name is another one. No, but class list add seems way better. Okay, cool. All right. So now what we need to do is say, okay, that's our one generation. What we need to do is set the next generation. So we're gonna have to, well, what we can do is just copy the row and then duplicate the row.
No, we can, oh, okay.
I think we're gonna have to make it not an ID though if you want to duplicate it.
That is true. Okay, so let's do that first. Let's get rid of. And let's call this a class. And then we want to get, what is this? It's query selector.
Query selector all.
I think that if we just do query selector, it will just get one. Yes.
Cool.
Because if we get query selector all, it would get an array. Yeah, and we would have to do
0.
Yeah.
No, that's too messy.
Yeah. Right. That works.
Okay. So now let's duplicate it.
Okay. Cool. So how do we do that? Let's duplicate the row.
Function. No, you're just gonna do it.
Function. Let's just duplicate row.
Yeah.
Row. And let's for now just do document query selector. I'm just gonna pick this is gonna be the first row. How do you clone a row?
There is a you need to get clone node is what we need. .clone node. Clone node.
Okay.
I like how we're working with the web API pretty
Yep.
intensely, like clone node, query
Yes.
selector. This is great.
Yep. I told you that this is gonna take way more time than we thought it would. All right. Document dot append child. No. All right. Jesus. Clone. Let's just see if this results in a new row. It did not. No.
Uncaught. Append child.
No. We have to append it on the.
We need to. I think we need to put it below.
Only one.
We need to append it to the body
Okay. So.
of. Oh. Okay. We probably need like another wrapper for the row, and then append it to
Alright, okay,
to
cool.
the, like, I don't know, wrapper automaton. Dove.
The dove.
Dove.
What? But, something like that.
Yeah. I think this would be good. And then we can append it, obviously, because then it's just
Right.
going to go to the bottom all the time.
Alright, cool. Document dot query selector.
Without the I.
Right, let's try this. It still doesn't work. Why?
What's the error? No error.
No error.
Clone first row dot clone.
No, it did clone the row. So it's cloning. It's just cloning the row, but it's not cloning the one
Oh,
below.
clone node, I think, takes a parameter whether you want to clone.
Oh,
But I'll double
alright.
check. Deep. Yeah, we want deep. We want
Deep.
all the children.
Alright, so
So it takes a parameter of deep, which is optional, and if
So
it's set to true, then we take the
okay.
children.
So it's
of the
just
node.
like this, clone node true,
Yeah.
right?
Yeah.
Oh, yes.
Cool.
Oh, awesome.
So
Right.
right now it's just like literally cloning it.
Yes, but we wanted to actually do the randomization on it as
Yeah,
well.
yeah. But the randomization is not going to happen. What we want to be able to do is now do the thing where we want it to change based on its neighbors.
Yeah, alright.
So,
Well, first of all, we want. I just want to do, like, before doing that, I want to randomize on the row, like we just created. Like right now, it's randomizing when it's creating the row.
you want to do the random after creation of the
Yeah,
row?
exactly.
Yeah, I think that would be a good idea.
Why is row? So it's gonna do. Just gonna move this in here.
But we're going to need to get the div.
Yeah, exactly. I need to pass that row div. And then I need all the. How do I get the children of a div? Like, is it just children?
Yes. Yeah.
It is. All right. So. Is that an array though?
Oh no, it's element.parent node dot child nodes. What?
What? Child nodes. Like this?
Yeah.
Let's just try that. I don't think I can do dot for each on it because they are not actually an array.
Why are you doing it for each? Oh yes, I
No.
see why you're doing it for each.
Row nodes length. They probably have length.
Let's
No, like-
how about we just console log row child dot child nodes?
Yeah,
first?
let's do that. Let's do that. Let's log that out. Okay, and we just gonna comment this out. And we're gonna do console, not randomize row, and we're gonna pass in this to begin with. It's a bit messy, but I'm just row is not defined. row you put. Okay, so I get
array.
an array. No, it's not. It's not an array. It's a node list.
Okay.
But it's kind of like it.
Can we see what they look like?
Where's their inner HTML? No, they won't. I'm looking for the outer HTML. It's just empty divs, which is what we expect.
Yeah, so I think it's okay.
Yeah.
Okay.
All right. Cool. Yes. That's
so then you can still iterate over it.
Yeah. Let I equals 0 row div. Child nodes dot length, while I is less than length, and I plus plus. And we want then the div is going to be the child node at the index. This might work.
This does work.
It does work.
Excellent.
All right, cool. So then we could, like hypothetically, do this here. No. Clone.
Yeah.
Yes.
Okay, but we're not randomizing it on the second
No.
try. But
Yeah.
That's
All
good.
right. I'm just making sure that it works.
okay.
All right, sweet. Now we have. So instead of doing this this randomization, we want to do like a proper automata randomization.
Okay. This is fine. We were doing the randomization on the first try. That's just for the first round because we want an initial random initial first state. Which is great. Okay. So after as we duplicate each row, we want to be able to basically set a state based on the rules we want it to follow.
Okay. Cool.
So I guess the next step would be to just set up rules.
Yep.
Okay. Last time I did this, I just followed. There's a website. We can just Google it. Atlas Wolfram.
What's it? Atlas.
Atlas Wolfram is. Yeah, that sounds a bit good. Yeah. Cool stuff. So we're looking at cellular automata
Yes.
in
Oh, up here.
this. One-dimensional, elementary, and we can pick a rule we wanna.
Oh, okay.
They describe what the rule is. I like 150. 150 looks pretty cool.
150.
Which one do you wanna do?
Okay, let's see. Okay, it looks like that. I want to do something different. What is this?
It's pretty cool too.
This looks pretty cool. But I wanna. This looks very ominous.
Then there's also like lines,
Yes.
and there's also black. Like 255 is black.
Oh, except like that little thing at the top.
Yeah.
Let's do. What is this? 73. Okay, let's do this one.
Okay.
Okay.
Cool. Let's do it.
Rule 73.
Let's leave the page open because we need to see these little things.
All right, cool. Oh, so these are the rule. This is the rules.
Yeah. So we're gonna say based on whether I am active and my neighbors are active, I'm gonna be inactive at the next stage. And if I'm inactive and my neighbor is active and inactive, I'm gonna be inactive. at the
Okay,
next
so let me get this straight. So this thing
is
like this it's going to be looking at like the things that are above it.
Yeah.
In the previous
Yeah,
generation.
in a previous generation. Yeah, that's a really good way to describe it.
Okay, cool.
Yeah.
That seems simple enough to me.
Yeah, I think it's straightforward.
Okay, so I guess that we implement this rule first in an if statement, no?
Yeah, I think that would be good. Yeah, let's start with that.
All right, cool.
Okay.
Okay.
I think we need a...
So a function to like process row.
Yeah.
I'm gonna just do this randomize row. Copying the randomize row and let's call it process row, and
We're getting child nodes.
so this is like the target node.
Target?
The what? Target.
Is that
Target.
is that in Swedish?
Target. Is that how you say it? Target.
I'm asking you. I thought that was in Swedish.
No, I'm trying to say target. Did I say target? Target.
Yeah.
Oh, damn it. People are always messing with me for not pronouncing just correctly.
Why?
And because I say in Swedish there is a word for you say just.
Oh, because your J's are youths.
Yeah, so so it's like I tend to say just do it.
Oh.
Not just do it.
That's a whole new
Yeah.
thing of Nike. Yes, do it.
Yes, do it.
Okay, so we grabbed the target. We got the child node.
Yes.
So what we then need to say, we
also need access to the parent row.
Yeah.
Yeah. Yeah. So
And we kind of need like the parent node to be more or less. No, yeah, we need the parent row access.
yeah,
basically.
because right now we are duplicating the first row.
Yeah, but
Yeah,
eventually
that-
we're gonna duplicate like the next.
Exactly. So this
row.
we need to instead get the last row. So I'm gonna break this out. I'm going to take all of the rows and grab the last one. And last row is going to be. Is there a function for this? Maybe there is.
Like get last child of like we can get the
Yeah.
last child of the automaton.
Yeah. I could just do all rows dot all rows dot length -1. I think that would work.
Sure.
Let's see if that actually works. Did it? No, I'm not calling duplicate row. First row is not defined. Where's first row? Where's that? Oh,
Because that should.
yeah, that's my old variable name. Clone node is not defined. Now clone node of undefined last row. Not getting this.
Let's console log all rows dot length -1.
Console dot log. Ah. All rows dot length. It's undefined. What? How does? Oh yeah. Now we need query selector all. Oh, now it works.
Cool.
Bam. All right. So we're going back to process row here.
So
Process-
we duplicate. We're gonna have to call it
Yeah.
duplicate row, and then pass in the last row.
Yeah, the
row.
clone and the last row.
Yeah.
Awesome. All right, so we are now looking at the target, and we now need target. I don't even know how to pronounce it correctly.
It is Target.
Target.
I'm sorry, I'm just poking fun of you. It's like you poke fun of my boot.
A boot. All right. We need. All right. So we need access to like the 3 nodes above it in its parent generation.
Yeah, so We can like set up like 3 different
Yeah.
variables, I suppose.
So like
Self,
parent 1, parent 2, parent 3, or ABC.
like self, right sibling, left sibling.
Okay, all right.
It seems like a better.
Like you. Oh, okay. Yeah.
Yeah.
All right.
Past self.
Yeah, exactly. So yeah, past self is it like, like my mouse per se is not suitable for this. So past self would be this one.
Yeah,
and
then
this would be left sibling, and this would be right sibling.
Yeah.
Okay, I'm with you. Cool. Let's reduce that again. Go back to our code.
And
So it would be like in parent row div dot child nodes and get like the I minus 1. And
there is a web, like the API for next element sibling and previous element sibling.
okay.
We can do that.
Oh, so I can actually, if I first get the self,
Yeah, we can.
I can do like parent row div dot child nodes dot I, and then I can do prev self dot. No, I can use prefer it here. Like previous, what do you call it? Previous sibling.
Previous element sibling. Left, which one's left? This one's left.
Element sibling. That like that.
Previous element sibling, yes. And then next element sibling.
All right, let's see if this. Okay, so we have the previous self and the left sibling and the right sibling.
Yep.
Now,
Do you want to unlog them just so we know?
yeah, let's do that. Prev self. Left sibling, right sibling. Okay, logging them out. This looks like some. Okay, we can actually see them in the debugger. Let's look at the top ones.
Previous
self.
Left sibling. We need to fix the problem with left sibling.
Why is that no?
Because it needs to read the very last child of the node.
Oh.
Because it's technically like.
Okay. All right. So it like goes around.
Yeah.
Yeah. All right. So if it's null, I guess it's have to revert to the last one.
So then we can do the parent row div child nodes
And the last one.
length minus 1.
Yeah. So dot length minus 1.
And yeah, and let's log this out and double check that works.
Yeah. Let's also I need to adapt it for like a huge font that I'm using. All right. Let's see if this worked. Okay, so that's the previous self.
And then let's do the
Left sibling is this. Yes, it's over there. Good.
and then cool.
And the right sibling. This works.
This works. This is perfect. Okay, so then if you see on the bottom, if you scroll down on the console all the way to the bottom, we need to do the same thing.
Oh, for the right sibling.
So then we're gonna get
parent row div dot child knows we're gonna get the first one. And we need to do the parent row div dot and it's just gonna be like the first one, right?
Yeah. Why don't we just
No, yeah, like I'm being retarded.
You're not. Not such a thing. Okay.
All right. And
Yes.
Yes.
Excellent.
okay,
Excellent.
cool. Yes. Good. So now we start applying the rule sets, right?
Yeah.
So this is
Well, no. Now we need to. I think to break it down a little bit more. Now we need to make sure we get the state, because all we need is the state
okay.
of each cell, right? Or the class. Class is the state.
Yeah. I don't get it. What do you mean? Like if it's inactive or
Yeah,
active.
yeah.
Alright.
We need to get the class list first to be able to figure out
Yeah. So we
which
need a function that can check if a
active
given
thing is active or inactive.
hang on is active row diff return row div. Is there a class list contains or something?
Yeah, I was just gonna say class list dot contains, and then active.
Yeah, I think this is what we need, right?
Yeah.
So-
Let's console log and double check.
Let's see, like let's just check if prev self console log prev self is active. Prev self. This should allow us to check it. Well, it looks good, sorta.
Sorta. Let's
Yeah.
okay. To the last two, the previous self.
Let's look at the first one. The first one is.
I forget. Is red active or is red
Let's
inactive?
switch that to your like active is red. Active is red.
Active is red. Yes. So previous self. Previous.
Yes.
Previous.
So it's like true, false, true. Yes, this looks good.
Yeah,
The first one is
okay.
true. The second one is
False.
false. True.
Excellent.
Yes, this looks correct. All right, cool. So can we implement the rules now?
Yes. Okay. Let's do it.
All right. So the first one, how does that? Okay, if all three are active.
If all three are.
Yeah.
Yes. If all three are active.
Yeah,
Like,
so-
is black active or inactive?
Yeah, exactly. How do we find that out?
I've remembered. It's black is active.
It's black.
Yeah.
Okay, cool. If hang on, is active, left sibling, and
This is gonna be like.
this is gonna be there has to be like a more clever way to do this, but
We can refactor. We can
refactor later. Prev self and is active right sibling. Then it should be inactive, right?
Yes.
Okay, we need to set into inactive. We need a function to do that.
Toggle class or something, or
No, it's not going to be a row. It's going to be. No, wait.
A row
This is
div.
not a row. This is cell.
Oh, Adam
Yeah.
lets you like edit two different.
Yeah. Oh, this is the best hotkey. This is my one thing that I really hated about using Vim. That this was so hard to get a hold of. I just hit Command D, and then both get selected, and I can do
That's cool.
cell div. This is
Cool.
like the only hotkey I use. All right, so where were we? The camera stopped, so we took a break and got some water. Like I think that before when the camera stopped, there was a segment where we talked about where we were. I don't think that got in there.
Oh, where we were
Like
in time and space continuum?
Yeah, exactly. Yes, exactly.
We're in Stockholm. Is that?
Yeah, exactly. Like we're in Stockholm.
Are we in Stockholm?
Yes, we're in Stockholm. And we talked about how we met at a conference in Brazil, but right now we're in Stockholm because we've both been talking at Nordic Jazz.
Yeah, which was lots of fun.
That was
I thought.
amazing.
Like,
That's
such
such
a good conference. Oh,
It's scary well organized.
I don't even know. It's so good. Like, I've never been to a conference that ran this much on time, and I think that's like super cool. I don't know if it's like a Swedish thing and everybody's just like on time.
It is a Swedish thing, I think, actually.
thing,
Yeah,
okay.
but it's also because they are very good.
Yeah.
I was on last at Brazil Jazz, and I think that my talk was 1 hour and 17 minutes after schedule or something.
But it was good. The conference was good too.
Yeah, it was really good, and like it was all Brazilians as well, so they're used to that, so it didn't really matter.
Yeah.
That was amazing as well.
It's awesome to be in Stockholm. I've been here once before, and that was 4 years ago or something. Things haven't changed. It's still clean. The water tastes good.
Yes.
The coffee tastes good.
Yeah.
Fika is great.
So we're going.
Can we go for fika?
Yes, we can. We should. And also that's why we're not in like the normal space. This is the last pair programming session that we made. That was with a guy called David, and this is his space that he uses to record his YouTube channel, which is called Data David, by the way. And that's also why it's super weird that he has these ultra squeaky chairs.
It's like you can't move without making
David,
so much
you
noise.
need to get new chairs. Like I think that when he sits and does it, he like has to sit super still when he does it.
Yeah.
And not use that one because that one is more squeaky.
I don't think he uses that one. I got that one from the other desk.
Yeah, I think he... Oh well.
Squeaky session.
Yeah.
Okay. What were we doing?
We were implementing the
Yeah.
first rule, and we just created this set is active function.
Yep.
And I talked about hotkeys. Okay, so this needs to get a cell dev. And it needs to return... No, it's not going to return anything. It's going to set it. It's going to toggle class.
Yeah. So it's going to remove the current class.
All right, cool. Is there a clear on the class?
I think we need to pass the class it needs to remove. It needs like an actual like active or inactive.
Ah.
Like there is classlist.remove and classlist.add, but you need to actually say which one to remove.
Okay. So
I can actually, let's double
all
check.
right. So if it's active, it should remove the active class. Cell dev. If it's active, then cell dev dot class list dot remove. It should remove active. Else it should remove inactive. And I guess that it should also set a new one. Add inactive. And then the inverse here.
Yeah.
Mind bender.
Okay,
right.
cool.
I think that's right.
Okay, that should be good.
And then it should set is active
To the...
this is now inactive, so it should be false. No, hang on. It needs to actually it needs to take
that particular cell.
Yes.
Which
the target.
The what, sorry?
Screw you. All right. True. No, false. We need to actually have that argument. We don't have that. Should be active. Value, maybe. And wait. Now I'm confused. Now this function is actually just toggling.
Yeah, so I think we need to pass it in.
No, hang on. If we do this, I think that
okay. Hold
this
on.
is gonna work, right? This is super weird, but if it's not setting it to active, it's going to remove any active class and adding inactive.
Yeah, but otherwise, okay. So maybe let's rename that value to remove, like, just.
Would that work?
Yeah, I think that's a little bit.
Yeah, that's a little better. Let's inverse
Naming
these
variables.
because this is super. I'm gonna change the order of these.
Bang bang.
Bang bang! Let's do that. Just for kicks. That's completely unnecessary because it is a bool. All right, cool. I think we implemented the first rule.
Yeah.
So let's see if that works.
Well, it's not gonna.
No.
We actually. Oh.
Do we call process row?
Oh no.
No.
Some of that did work because we were only checking for the all active ones, so it does work for those. We just need to implement the next.
Yeah. All right. Cool.
Okay.
All right. First rule done. And we go. We'll just continue.
Yeah.
I guess. It can only do. Hang on. Yeah. Sure. Right. We're just gonna do else if.
It's fine. Let's look at the.
Let's look at
I
the
don't
thing.
remember.
Yeah. Okay. So if the first two are.
I think if the first is active, left sibling.
And is active prev self. And the other one isn't. Right sibling.
Yeah.
Then
Do the set active.
it should be active.
Yes.
All right. Cool. I'm feeling a refactoring coming on here.
No
Seems
shit.
like let's do one more. Is active. If the first one is active, and the middle one isn't.
Previous cell. This is like the questions of existence here.
And if the right sibling is.
Oh, by the way,
that
that one should be bang.
Yeah. Bang, bang, bang.
Just single bang, no bang
one
bang.
bang, bang, bang. And then it should be false.
Yeah.
All right, cool. Okay, let's refactor this. This is getting crazy. Can we somehow? How would we do this? I'm thinking.
Okay,
what
I think we don't have to do it for every single one of them because in some instances of those rules, we're just gonna leave the cell as is. So I think if the cell stays the same way. See, like here the cell has to change, here the cell has to change, here the cell has to change. So in all other instances, we actually don't change anything. That's not a refactoring point. That's just like a point that we don't have to do an else if check for everything. We only have to do it when the cell actually has to change its class, because otherwise we just keep it the same.
Yeah. I kind of want to do it like deterministically.
Okay.
But I'm thinking that perhaps we could just do a function that takes all of. I want to do this with currying.
Let's do it with currying.
Yes.
Oh my god.
Functional programming. Because I'm thinking that I want to create a function that takes the set based on rule. Bear with me here. This is going to be awesome.
Okay.
And it's going to take the target and it's going to take the left sibling, it's going to take the previous self, and it's going to take the right sibling, and it's going to take a rule, set active if matches rule. Okay, cool. And we're gonna copy some of this, and I'm gonna have the rule be like an array of numbers. So, or ones and zeros, I mean.
Yeah, like a lookup table.
Exactly.
Perfect.
So
I like that idea.
So let's say we have a rule that is something like the first rule. It's going to be something like this. And then we need to check if the first one matches this state. So I'm going to...
Oh! Why don't we, instead of... Because is active can just return a 1 or a 0 instead of...
That's much better, yes. We call this state. Oh, that's much better. And we
return if active, return a 1, otherwise return a 0.
Excellent. So state left sibling equals rule 0. This. And that was really clever. I like that a lot. And rule 2. So matches rule. And if it matches rule, it should set is active on the target. And true. Otherwise it leaves it, right? For now.
Okay, so we need to set up a rule table somewhere.
Yes. All right, so let's do that. So first I'm going to make the carried function.
Okay.
I'm just gonna I can't think of a good name for now, so I'm just gonna call it X. We're gonna name it later. It's gonna take set is active match rule, and then I'm gonna do a bind. The first argument we don't care about, but then we're gonna give it the arguments that it needs. So it needs target and the siblings.
Okay.
So it's gonna get target and the left sibling and the right sibling and the
previous self.
Yes, and the okay, that's the wrong order.
Is it? Yeah.
I think so. It's gonna be left sibling.
Get rid of the other left. You have 2 lefts.
Oh, okay. Now I'm with you. So this will now create a function which has all of these arguments like appended. So once I call this, I can call it with just this because all of the other ones are filled in. That's currying.
Yeah.
So I can now do like a rule, like 1, 1, 1. This should be the same thing as the first one, I think.
Yeah.
I think
1, 1, 0.
0 and 1, 0, 1. Let's see if this works.
Let's try.
If I thought this through correctly. bonk. Does this look right to you?
No. These are not working clearly.
Okay, so let's. This one is
Active and active. I need to. Actually, yeah, I can pull it out on my own. What rule are we doing?
We're doing the rule 73. I'm just gonna do one.
No. You just did the first one, right?
Yeah. This is just the first one. So if it contains active, it's going to return 1. Otherwise, it's going to return 0.
And 111, like that should not be getting changed at all.
Exactly.
Because only the red ones should be changing. At this point, if we just have to.
Yes, exactly. So if 111. No, wait. Hang on. We also need to actually. Yeah, because this can now it can only the rule has to actually have a destination, like a target value.
Okay.
Like this, matching this rule makes it inactive or inactive. Right now it's only being true. Hang on, this is a bit messy, but I don't think so.
Oh, you wanna like the true and the not true.
Yeah, exactly. Rule value. I'm not sure exactly what to call it.
Gotcha.
Set is active, rule value, and so this is gonna be like, then it should be false.
Okay.
Yeah, so that might be one reason why it didn't work. How does this look? If all of them, okay, here's 3.
Goes to that. I don't know why that got changed. Like, see, the red got changed too.
It doesn't necessarily have to be changed. Like,
yeah. So this is fine. This is looking good. This is looking good. These are looking good. These are looking good. These are looking good. Okay.
Okay. So far. Okay.
Now let's get the other ones in.
Okay. So hello.
Okay.
Okay. The second one is 110. Whoops. And that's supposed to be true.
Yep.
And then we go and
0 1
0 1.
and that's false. 1 0 0 and that's also false.
And what's next?
0 1 1.
0 0 1 1.
Oh, here I can do that.
Yeah.
How does one do the
yes.
brush stroke?
It's
okay, but I'm sorry.
One.
Yeah.
No, you can do it.
I can see.
0 1 1. And that's true. And then
0 1 0.
0 1 0. And that
0 0 1 0.
0 1 0.
I do that actually quite often. And then that would be false. And 0 0 1.
0 0 1.
And that's false. And 0 0 0.
0 0 0. And that's
true.
True.
Have you ever done combinatorics?
Maybe, I don't know.
It's like that weird math class you take. And I don't know, we had like this subject. It wasn't like an entire class on it, but there was like a chapter.
Not sure if I'm familiar with combinatorics.
It was like basically like computational things like this, like figuring out all the possible permutations.
Okay. No, I don't think
I've done that's when you do like the bang thing as well too.
No, I've definitely not done that. I have no idea.
It was like an interesting, like a weird / interesting / oh my god, we're just doing numbers class.
Oh, interesting.
Okay. Anyway.
Like, can we find out, like, decide a good name for X?
Yeah, let's do toggle class by rule.
Oh, that's good. Hang on. Something like that.
Yeah. Do we have another toggle class after? Did we call something toggle class before?
No.
Okay.
Cool.
Okay.
I'm just gonna tidy this up. So that it's possible to view in the screencast. Alright, cool. And I can remove this because it's...
All the rules.
Alright.
Okay, let's look at what it does.
Does that look right to you?
Have to legit double check. Inactive. No.
So...
Like even these ones, so active, inactive, that should stay active.
Okay, so we have... Which one is incorrect? The second one.
Second one.
So this is active,
Active,
inactive, and that's true.
True.
Alright, so this is not working for some reason.
We need to switch the false on the true.
Oh, we do?
No, this is fine.
No.
Yeah, if class is active 1, I think is active if it's inactive. If the class is inactive, we need to add active.
Oh, or well, hang on.
No. I think we're just setting the true and the false wrong. It's the opposite.
So toggle class set is active. No, but like this, for instance. Hang on, let's double negation. Right. All right. So this one, this is like if this is active and this is active and this is false, then it should be true.
Yeah. So is active is true.
So I think that this is a correct signature.
Yeah, but that means we don't need to remove class. Hold on, scroll down to the is active.
So if it is active, we should remove inactive and add active.
Yeah, okay, no, that's right.
I think this...
No, the logic is fine, yeah.
This looks right to me. What is happening here? Oh, sorry. Debugging. Set active is matches rule. So we have a rule... Oh! Yeah! Used copy-paste programming. That's... yeah. Alright, let's see how this looks.
Active, inactive. Active, inactive. Active, inactive. Active.
I feel like you're like, I've done a test and you're checking if I did the right thing.
You can help me check.
Yeah, okay. All right.
No, I think it looks fine. I've checked the first 6, it's fine.
Yeah.
Yeah, okay. So I think this is good. So now what we need to do is we need to keep duplicating the last row.
Yeah.
And just do like a set timeout or something of the sort.
Okay, cool. So let's see, duplicate row. So this would basically, if I do this, it should just...
Yeah, but I mean, yeah.
Well, it... Yeah.
Yeah.
Okay, so let's just set timeout it. I don't know why I want to move this down here.
We can just do a loop and...
yeah, I'm just gonna do set interval.
Yeah, that sounds good.
Control.
1 sec.
All right. Moment of truth.
Set interval duplicate row 500.
Yep.
Okay. Cool. Cool.
Does this look like the Paranother one?
No.
No. No, this is just alternate. No. There's something wrong here.
I forget. It's just duplicating the... What's it doing? Okay, the space in between is kind of bugging me. It's hard to tell.
Okay, shall we remove the space?
The margin, can you make it 1 pixel instead?
We can actually... Oh, sorry.
Yeah. Yeah, something's up here.
Now, it seems like it's just alternating 2 rows to me. No, it's not quite doing that either.
Oh. No, that seems about right.
Oh, perhaps it is right.
Yeah, and there's like... Yeah, there's like these little flying saucers too.
Yeah.
If you actually pull it up on Wolfram, so then folks can see.
Oh my, hang on. So it's...
if you scroll down...
Here's something.
Yeah, that's not a random initial state, but it has like these little saucers.
Yeah.
This is a set initial state.
Oh, okay.
That gets like that. But if you look at the random initial state...
Perfectly random initial condition.
Yeah. That looks like our thing.
It does, right?
Yeah.
Oh, no, I've messed it up. Hang on. I'm gonna remove like the margins a bit and have a height of...
Remove the entire margin. You kind of don't need it. Just a class or kind of... Oh, sorry.
Yeah, exactly. Hang on. I'm gonna change it to 4.
Yeah.
This is what it should look like.
Cool.
Yes. Oh, this looks really cool.
This does look so futuristic. Okay, we need to make a GIF out of this.
This is amazing. This looks... okay, I'm getting why people like this.
I'm telling you, this looks like spaceships moving in space. This is a pretty good art form. Like, good choice of colors.
Yeah. There was no choice involved.
I wonder what the author was, what the artist was trying to say by this choice of colors and these flying saucers.
Yeah. This is mesmerizing.
Okay, can you make it faster?
Yeah.
Let's increase that set timeout.
Yeah, let's do 100 instead.
Yeah. Whoa. Trippy.
Okay, I would kind of like, I would love to have this as, you know, like an e-ink display.
What's an e-ink display?
You know, like the Kindle.
Oh.
But with color, and you could have this as paintings on your walls.
Oh, totally. I would put this up on my wall.
That would be, how, like, hang on. E-ink display, how, because I know that Samsung won like CES by having like these huge e-ink displays with color.
Okay.
That were reasonably priced also, I think. So you could do like paintings with these things at home. So they're not actually, they aren't backlit or anything. They are just, and they consume almost no power.
That's amazing. Can e-ink, yeah.
Is this Triton? How much are these?
That is like, oh, it's like subdued color.
Yeah, exactly. But I think that there are e-ink. I think e-ink hair. Yeah.
It's a nice, it adds like a nice little filter to the whole form of art, I suppose. Okay, can we just like look at it one more time?
Yeah, absolutely.
So good. Okay. Oh, you don't have the...
It's amazing. I'm gonna like just... I'm gonna... What if I...
So good.
This is very cool.
This is very cool. If you look at it long enough, it looks like the lines are kind of just like wavy. No, you don't see it?
No, I think it's...
Maybe it's my angle. Maybe I've looked at this for too long.
Yeah.
Maybe I've been looking at these for too long.
It has messed you up permanently.
Yeah.
Hang on, I want to remove the margins of... at the end of the body margin 0, or perhaps it's the padding. No, what's the margin? Oh, that messed it up.
It's because the zoom and the lack. Your zoom is at 400. Command 0.
Command 0?
Yeah. Clears.
Oh, interesting.
Clears.
I'm gonna set this to 8 instead.
Nice.
That's pretty cool.
That's pretty cool.
I like this a lot.
Yeah.
I think that's a kind of if we just do one, I think it's better, like, instead of us doing one more, I think that we should encourage the audience to go do these.
It would be super awesome to see what comes out of this. I know, like, you can just follow the particular rules and build this out and get different patterns, but I think a lot of people, what they've been doing is applying these concepts to other things, or like sound.
Yeah.
Or images.
Sound is so weird. Like, has anybody done that? That is like super cool.
I shall maybe let you know in a little bit.
Oh, I see. Right.
But so I mean, like, you can apply this to anything as long as you can convert something to a binary state.
Oh, yeah.
Like, if you think about it, like, you can apply any of these rules to anything that can be made into a binary state, already has a binary state.
So how would, like, so you mean, like, for instance, like, if we took an MP3 and, like, mangled that in a way that it just got us a binary, like a string of binary ones and zeros,
yeah,
we could make and use that as the basis for this and create one of these from that.
Yeah, or like maybe an easier example would be an image, and if you grayscale an image, to something to just the binary states, if so, and then check whether something is gray or if something is white, if something is black, if something is white. You're then able to apply a rule and make automata out of the picture and then convert it back from the scale.
Okay, I see.
So that would might be an easier way to visualize it, because sound's kind of mind-boggling.
Yeah, that's weird.
That's weird. Images are easier.
But either way, so like if one would like to read up a bit more on automata, what are things that people should check out? So we can leave people off with some reading.
So I think,
first of all, these examples, like, where did they find, like, the link to your GitHub repository, like the original green thing? That's online somewhere, right?
Yeah. It's going to be in my GitHub, and I'm LRLNA on GitHub.
Yeah.
And it's one of the starred repositories I have. I like
link in the episode description.
Cool. And then I think where we got the rules from, so atlas.wolfram.com is pretty great for just kind of seeing what you can do and kind of looking at other different systems. So 2-dimensional automata, 1-dimensional automata, and all the kinds of different ones you can have, and they actually write pretty good descriptions. How I got started in this was a book by Melanie Mitchell, and she talks about complexity. So she doesn't specifically talk about automata, but she talks about complexity, and she talks about entropy. She talks about how people got computers built, basically, and things like that. It's a very wide range of different topics put together in one piece of literature that's very accessible. It's not like a book of mathematics, which could be cool, but like that one is not. So I found it to be very accessible for myself to read. I think those are like good basics to start with.
That's cool.
Until you get into more complicated or more interesting things, if you like.
All right, sweet.
Yeah.
If you do one of these, make sure that you post a link to it in the comments to show.
I would totally love to see that. That would be so cool.
That would be so cool. All right, so that's a wrap.
I wanted to say thank you for having me.
It's been so awesome. Thank you so much for coming.
No, thank you for being
I got
doing this super cool pair programming session.
Yeah, people are asking for these because they love the last one I did with David, and I've been wanting to do one for ages. It's just that you have to go to Stockholm and find somebody to do with, and so I'm just so happy that
there's nobody's in Gothenburg.
Yes, but no, nobody lives in Gothenburg.
I'm so sorry. Maybe you just have to travel places.
I think so. Yeah.
Yeah, that would be cool. Just let's
travel places where there's also a studio. That's a tricky part.
I think I don't know if it's a big city.
Yeah, I think it's doable. I just need to do it. All right.
You can do it.
Yes. Okay. Right. Outro time. Now, I'm trying to do this 3 times now before. All right. You have. All right. 4 times.
Do you want me to do it?
No. Oh yeah. You can do it. Yeah. Do it. Okay. Do it. All right. So this is the text.
You have just watched an episode of Fun Functions. If you like this video, please share it with a colleague. I think that would be nice. If you are that colleague, you have just watched an episode of Fun Functions, as I just said. So, Matthias, you release episodes every Monday? Is that right?
I do. Yeah, every Monday morning.
Every Monday morning?
Every single Monday morning.
At 8 GMT, is that what I hear?
Yeah, 8 a.m. GMT.
So what time do you... Okay, so 8 GMT, new episodes of Fun Functions. Don't miss out, and I think you should subscribe.
Yes.
There's a subscribe button somewhere.
Yes, there is somewhere.
Somewhere. Cool.
All right.
Yeah.
Until next Monday morning, stay curious.